As we move away from redox reactions, I don't want you to leave this thinking, I can't believe how much worthless work I was given to try to do this balancing redox reactions. Is there really any point in having done it? The thing that you need to take away from this is that regardless of whether you're ever asked to balance a redox reaction again, it is an appreciation that when a chemical reaction happens, like this one right here, in which you have an oxidation and a reduction occurring, that for this reaction to happen, electrons have to flow, and that you have to get used to this idea of this cycle that's taking place here of electron flow, in this case as you have an oxidation occurring, and in this case as a reduction occurring. And that process of electron flow is what makes a battery. It's what makes a redox process happen. I'm about to show you a whole bunch of batteries. And for every battery I show you, always be aware that there is a half reaction which is an oxidation and a half reaction as a reduction. You'll know this because you'll actually see that as I show these to you, they are separated in space from each other. So here's an example of electrochemical cells. Here's an example of batteries. And in the traditional way that you're shown, where you are working with literally two beakers, these two beakers represent the separation of an oxidation process from a reduction process. So you can see that beaker right there, that kind of orangish one? That's the beaker where an oxidation was occurring. You see that beaker right there, that one right there? That's the beaker where the reduction was occurring. That corresponds very specifically to one of the beakers being this and one of the beakers being this. We don't do our electrochemistry in beakers when we want to do something practical. We put them into batteries. But understand that sitting in this battery is this physical divide between a place where oxidation is occurring and a place where reduction is occurring. Here the physical divide is pretty obvious. It's this salt bridge that I have here between the two systems. And I have this circuit which is being created here that allows me to watch the flow of electrons like this, so I can measure the potential energy difference across this system as measured through this voltmeter, and see that it's about a half a volt worth of potential energy difference, of half a volt worth of possible work that I can do. Well, that's taking place here in this battery too, and in fact in every battery that you'll ever see, whether it's a Duracell copper top battery, or whether it's a lithium-ion battery, or whether it's a lead-acid storage battery. In every case, I have created these two compartments sitting within the battery, one where the cathode is, where the reduction is taking place, and one, an anode, where the oxidation is taking place. And in every case, there's a flow of electrons that I'm trying to tap to go do work. And the amount of electrons that comes out of there across the potential drop that occurs between the oxidation-reduction process is in fact the energy that I realize from an electrochemical process that allows me to do the work I need.